Okay, so next we're going to put in an Axiom solver. Oops, Axiom solver. Okay, I think this is version, not sure what version this is. It doesn't tell me. Maybe it tells me here. Okay, I'll be right back. Okay, so this is Axiom version 1B005. Okay, so that's what that is. Okay, good. And if you look at the left input, it's source VDBs, and the second one is source shapes. All right. I do want to point out something. So here's CG Circuit. I'd like to recommend two courses in particular. Okay, one is Applied Houdini Volumetrics Bundle. Now this is a fantastic bunch of tutorials by Stephen Nipping. You cannot miss this. This is a fantastic, full of information course. Okay, the next one is FX Mayhem, and that is by Stefan Broderick. And this course specifically talks about Axiom. All right, so I recommend these two courses for you. Check it out. Okay, so I'm only gonna scratch the surface of Axiom Solver here. Okay, so obviously if you want to know more about it, FX Mayhem is a good course for you to check that out. All right, good. Let's move on. So I'm going to create VDB from particles because these are particles. Okay, so I'm going to connect it to here. And I'm going to reduce the voxel size to 0.02. So you can see it's appeared now. Okay, good. I'm going to uncheck that and check fog VDB. Okay. All right, good. So if you now click on here, we've got density coming in. All right, but we need fuel temperature. We need fuel temperature and velocity as well. So let's add 3 attributes here. Okay, and the first one will be fuel, second one temperature, and the third one velocity. Okay, so this is important. For now, in Axiom Solver, it takes fuel, temperature, and velocity and other stuff, and everything is in the sourcing. So if you hover the pointer over here, it says source density, parameter, source temperature, etc., etc. Okay, and it'll also tell you the collision parameter and etc. Okay, good. But for now, so I'm actually going to point out something here, right? So here, if you hover the pointer over collision temperature, it says collision temperature with a capital T. If you don't put it exactly as it states there, it's not going to work. However, for these ones, I was able to get away with just calling them temperature, density, temperature, fuel velocity, and pressure. Okay, so I'm not sure why that is, but that's the way it is at the moment. All right, good. So I'm going to connect it to the source VDBs, which is the first input, not the second input, because the second input has its own sources, which are called source shape. Okay, we'll come to that shortly. All right, but for now, that is good. So I'm going to call this VDB name fuel, and this one temperature, and the next one is VEL, velocity. All right, but for velocity, I'm going to change it to displacement, velocity, acceleration, and yeah, these ones are fine, I think. All right, good. So let me zoom out a little bit and set up a camera. Okay, something like that for now, anyway, at least. Actually, okay, something like that. All right, pretty good. Okay, I'm going to click on this. Maybe I shouldn't have done that. Okay, I'll show you why. Okay, it's back now. The reason it took a long time is because I have dual GPU here. Okay, so and the solver automatically selects my Intel R UHD graphics. I don't know why, but anyway, I'm going to change this to manual, and I'm going to pick a device which is RTX 2080. Okay, 2080 with Max-Q design, which is much faster. All right, so I'm going to save it for now. All right, I'm just going to run and see what comes up. There you go. Something's happening. which is pretty good, and it's pretty fast, as you can tell. All right, I'm just going to change the display to dark. You can press D and it'll bring up display options for you. Okay, so that's what it looks like at the moment. All right, good. You can tell that the quality isn't as great as whatnot. Right, we're going to check that out. Okay, I'm going to bring the division size to 0.05 just to get a better quality for now. And the solver mode, I'm going to change it to reflection because it's a lot better compared to traditional. All right, you get a lot of these swirls when you use turbulence and disturbance fields. Okay, that's what that is. And I'm going to change the performance to memory efficient because I want to bump up the division size to as much as I can. And if you put it on speed, it's going to run out of memory pretty fast. So I want to keep it at memory efficient. Okay, I think that's about it for now. And this is fantastic here because this actually gives you some information, and it says nice for RTX 2080. Anyway, so good. So it says 2.56, playing it safe. And if I bring this down to 0.02, I think that changes. Okay, well, it still says so many gig arrays. Fine, fair enough. So I'm going to change this back to 0.05. That's all for now. And I'm just going to run this and see how that looks. Okay, you can see it already is starting to look a lot better. Okay, but we'll refine this. All right. What I'm going to do is I'm going to put in a pyro big volume node here, just so that we can visualize what's happening. Okay, so the smoke is enabled, and I don't mind that at all. That's fine. Let's go into scatter and enable scatter there. And those settings are fine, actually. Let me just run this first for a few frames. Okay, 48 frames, that's good. Right here, there you go. It's starting to come up now. That's pretty good. And I'm also going to go into fire, enable fire. And it changes completely, as you can see. And I'm not going to change much, okay, apart from enable masking. So yeah, I'm going to leave it at that. All right, pretty good. So I just wanted to, I just want to visualize it. That's all really, nothing more to it. Okay, good. You save it. Okay, so I want to talk about this, right? So if you look at it, I want to create a ground plane for our source so that it doesn't go below, So the easiest way that I found how to do that is by putting in an Axiom source shape, and I'll hook that up here. But I'm going to create a box here first. So if I click on this, it comes up like that. All right, that's not very good because we don't want that. We want a box in here, and we want a box, so like that. And we want to change the type to collision. All right, so it collides. This is all set up for you, okay, by Matt anyway. So I'm going to hook up this box on the top here because it says here reference shape. So now you can adjust the shape, and that'll adjust the Axiom source shape. Okay. So what do I want? So let me see. I want a grid, which is about 10 meters, and then I'll bring it down to -1, and then I'll increase this one to 10 as well. So it's kind of like that. And I'll copy this and paste it here and divide it by 2. Okay. So let's look at the front view. That's the front view here. And you can see it's lining exactly at 0 level. All right, that's perfect. So now if I click on this here, you got a whole bunch of stuff here. But the collision shape, the collision temperature and velocity are already defined in here. Okay, so we don't need to worry about it. Which reminds me actually, so if I now click on this, originally we only had density, now we have fuel temperature, velocity, and density. Okay, that's important. All right, good. So if I click on it now and go back to 1, and okay, so I'm going to go back and I'm going to start playing this. So if I look at front view, now you can tell that it's not going below, all right, which is good. Perfect. Okay, let me move on to Axiom Solver here in the sourcing tab. What I want to do is I want to increase the temperature by 4, all of these by 4. Okay. Okay, you know what? I'm going to leave them all at 1 for now, and then we'll come to that later. I'm going to move on to simulation. The important thing about fire is that it's usually faster compared to an explosion. So I'm going to change the time scale to 2 already. Okay. And if we need to reduce it, we can reduce it later. It's up to you, all right? But I'm going to leave it at 2, I think. And I'm going to change the dissipation to 0.05 because this is the density dissipation. So if you dissipate it too much, it's going to behave like steam. I don't want that, okay? Just going to change it to 0.05. But I do want diffusion. I'm going to change it to 0.1. Diffusion is the amount of blur that is on the density. Okay, so all right, that's good. By the way, I've explained a lot of this in my other tutorials as well. So if you browse around my my YouTube channel, you'll see a lot of fire tutorials, realistic fire, I think 2 of them at least, and then some explosion tutorials. So check them out. All right, so cooling rate is very important. Okay, so because this is a fire, I don't want it to last any longer. I mean, I don't want it to last too long. Okay, so I'm going to bring the cooling rate to 0.2. Again, you can adjust these parameters, you know, and try it out yourself. But cooling rate, basically what it does is it cools down the temperature. How quickly the temperature will cool down per timestamp. Okay, that's what that is. And I do want the temperature diffusion to be very, very small. If you have very high temperature diffusion, the smoke itself is going to look really good. However, it is also going to take out a lot of details. So it is a balance between detail and blur effect. It's the same blur effect as the density. It's just this is on temperature instead of density. Okay, so I'm going to leave it at 0.01. All right, good. Okay, so as we know that the fire didn't really go up that high. Okay, first of all, I'm just going to put this back to 0.1 for now, all right? Because I think we need to test this. Right, so with buoyancy 1, so that's what you're seeing. It's barely rising, okay? So I'm going to change this to 10. And you'll see suddenly it's going faster. But it's the resolution is too low, so it's not, you're unable to see very well. So I'm going to have to increase this, I think. 0.06 maybe. So it goes up a little bit better than previously, all right? So we're going to work on that and continue. Buoyancy is the force that pushes the flame upwards. So it'll tell you how buoyant the fluid will be based on the temperature field, okay? The temperature field is obviously very important. So here's where the sourcing comes into play. So I want to change this to 4, 4, and 4, just like I was trying to do earlier, okay? So I'm going to run this, and I'm going to see how it looks now. Yeah, so it is going up, as you can see. It's a significant difference. But what I want to do is I want to change the fuel to pull rather than add, because I don't want to be adding fuel to it all the time. I want to just keep it and I want to pull it, all right? So you wouldn't see much difference at this moment, but at the end, we will change this to add and you'll see a significant difference, all right? So for now, that looks pretty good, and I'll move on to simulation now. Okay, so we have a bunch of stuff here, and turbulence is already turned on, okay? And I want to turn this off first. I want to turn on wind, and I'm going to leave it as it is, but there is a tab here wind. Which direction do you want the wind to go? I want it in the negative X direction. Okay, so it's gonna go that way, right? So let's check it out. So you can see it's starting to behave that way already. So it's going that way, which is pretty good, I think. All right, perfect. I mean, you can change it to whatever direction you want, really. It doesn't matter. The gravity is already set up here. I'm not going to touch it. Okay. But I want to start adding these fields. First is disturbance 1, disturbance 2, turbulence 1, turbulence 2, and confinement. I want to add all of these. All right. And if you go into down here, disturbance field, you have block size. Now this is very well explained in Applied Houdini, Stephen Napping's tutorials. Okay, check them out. But I will try and explain it as much as I can. The block size determines the size of noise details or turbulence details. The smaller it is, the smaller the disturbance will be. Sorry, not the turbulence. Disturbance will be. The higher it is, the bigger the disturbance is going to be. All right. So first, let's look at disturbance 1. Cutoff field is what field should be used for cutoff. So anything above this will not have, anything above this value will not have the turbulence effect in effect. Okay, so the disturbance field will only affect fluids whose field value is less than this value. So anything above 0.2 density, the disturbance will not come into play. Okay, so I want to change this to temperature because that's what I'm interested in, not density. Okay, and I'm going to leave the cutoff at 0.2. That's fine because our temperature ranges from 0 to whatever. I think it's 2 actually. But anyway, so I'm going to leave it at 0.2. But I do want to change the control field to velocity because I want the control field. This will be like, it's my understanding that if you have a control field and a cutoff field, so the cutoff field multiplied by the control field is how much the disturbance is going to be affected. For example, the temperature's got to be below 0.2 or 0.2, and then the velocity's got to be at a certain level for the disturbance to come into play. Okay, that's what that means. All right, so I'm going to leave it that is. I'm going to leave it as it is, and I'm going to move on now. All right. So hopefully you understand that, and I'm going to also check this block size. Okay, so division size multiplied by 2. So the minute you change the division size, which is here, that is going to change. All right, so that's important to know. All right. So that's why it is important when you're trying out the fire to try out as close to the final resolution as possible because it can change significantly. All right, but yeah, unfortunately that's the way it is. All right, move on. Disturbance 2. Disturbance 2, I want to use the cutoff field fuel here instead of density because we already have it on temperature. Now I want to move it to fuel, okay, on disturbance 2. Okay, so I want to leave the cutoff field at 0.2. But this time the control field is going to be temperature instead of velocity. Okay, so the fuel's got to be below 0.2 and the temperature's got to be somewhere around regions of 1 for this disturbance to come into play. Okay, again, you can play around with this all day and changing these parameters. You know, it's going to give you different results, and this is the best setting that I found. Okay. I'm going to move on to turbulence now. So turbulence are the little details. Okay, so you know what? I'm just going to run this through now. I'm going to see. Okay, hopefully you can see that there is a little bit of difference between the first one and this one. Okay, because you can see all of these leading edges here. Okay. All right. Good. So maybe I should do a little flip book on this. So 48. Oh, no, not that one. Oops. Not that one. This one. So I'm going to do a little flip book so that we can compare. Okay, so here's the one with none of these turned on. Okay, accidentally I left the confinement on, so I turned it off, and then I did the flipbook. So this one is with both of these disturbances. Okay, so there you go, and that one. So you really cannot tell much difference apart from around here, this region compared to here. Okay, so these are the leading edge, and that's the difference at the moment. So we're going to continue working on it, and we're going to add these, and we're going to create flipbook, possibly at every stage. I'm not sure. Okay, let's do it. So I'm going to add turbulence 1 and 2. I'm going to jump right into turbulence tab here, right? So I'm going to change the, I'm going to leave the type to permanent, but I want to change the scale field to velocity. I want to affect the turbulence 1 where the speed is at a certain level. Okay, so I want the speed to be set at 8 because that's really the speed. I mean, you can check the speed if you like. For example, if you put in a trail here, and I have some presets, maybe not trail, sorry. Where is it? Velocity trail. You got an Axiom velocity trail? Okay, that's good. I didn't know that actually. So there it is. So there's your velocity. Maybe no. Z-axis is what I want. Okay, good. So now if I run this, you can tell that is the velocity right now. Okay, so how do you calculate speed from it? If you go into the parameter, so hopefully you should. Okay, I can't see it. I'm gonna create another one. Okay, so velocity. Okay, it's called volume slice. Okay, so if I put that in, and I have some presets here. Okay, maybe not. I'm gonna change this to velocity, whatever. And I'm gonna source group at vel. So you can see, there it is, and you've got your velocity here. Okay, so how do you calculate speed? So if I put in a point wrangle here, and I'm going to say at f at speed equals length at velocity. Okay, that'll give me my speed because velocity has both speed and direction, and speed only has speed. Okay, how fast it is. All right, so now you can tell what the speed is, right? So and here I'm going to choose 8, where it says how quickly the noise pattern will change. 1 will change the pattern every second. So I want to change it to, I want to change it 8 times every second, basically. And that is the speed we just calculated here. All right, that's good. Okay, let's move on. So I want the swirl size to be small. I don't want too big, so I'm just going to choose like 0.1, maybe, I don't know, 0.2, I suppose. And then I want to change the gain a little bit. It's hard to really show you here because I can't change it on the fly. Okay, so I'm going to give it an arbitrary number. So about 1 point, yeah, something like that, 1.5. It's pretty good. And the control field, again, it's going to be velocity. And I'm not going to change the input range from anything but 0 to 1. I know that our input range is 0 to 3 here, or 3 point something. But I'm going to leave it at 0.1. All right, 0 to 1, sorry. Okay, let's move on to turbulence 2. Here, I want to change it to simplex because I want a different turbulence, really. And this will be based on fuel. And the swirl size will be slightly bigger. Let's call it 0.4 maybe. Okay. So, and I just want to show you this as well. Okay, I'm just going to get rid of this. I'm going to show you this, right? So now if I choose temperature, you've got just the temperature coming in. All right, and if I choose density, you can see where the density is, but there is no fuel. And that's because if you go into Axiom Solver, I'm just gonna go back. In output, you can export output fuel fields, okay? But for the fire, we don't need it, because if you export fuel, it's going to add data, and that means a lot more storage is required, okay? So bigger file size. We don't want that. But for now, I'm just going to show you this, right? So if I show you the fuel, you can tell where the fuel is headed basically. So if I push this, yeah, there. Okay, so that's actually density. Sorry, I need to change it to fuel. There you go. So there's the fuel. It's barely rising, and this is important to notice, all right, or note. It's barely rising at the moment. Okay, we'll come back to that. All right. So I'm going to leave the fuel output as it is at the moment, and I'm going to go back into simulation, and I'm going to change the turbulence to settings, or continue to change it. So I want to give it a gain of 2. What is the gain, right? So here it says, it doesn't say anything. So it basically adds, all right, to the turbulence, right? And then this one will also be dependent on velocity. And this will play a major role, because although the fuel isn't really showing up here that much, which means it's not going to really have any impact. However, if I go into combustion tab and enable combustion, which I should have done from the start, but anyway, you see this advec fuel. Now, if you watch what happens to fuel, you'll see that goes up, and this is imperative, because without this, you won't get the effect. All right. Now, if I were to go back and uncheck advec fuel, check this out. Nothing. The fuel is not being advected. Okay, and that's important. All right, good. So hopefully you get that, and I can actually now get rid of the fuel. That's fine. I'm going to get rid of this as well. I'm actually going to keep it. All right, fine. So we'll go back into simulation now, and we've set up turbulence 2 as well. So what else is there? There is confinement at the end. So actually, I'm going to run a flipbook, and I'll come back. I'll actually uncheck combustion again, and I'll run another flipbook, and I'll come back. Okay. Okay, so there is all of them running in parallel. This one with no disturbance or turbulence. This one is just with disturbance. This one is with disturbance and turbulence. So you can see the difference between, it's getting better and better, okay, without increasing the resolution, right? Maybe you can't really that much, but it's going to get better, all right, I promise. All right, good. I'm going to just stop these. All right, move on. So last one is the confinement. Confinement, what is confinement? It adds small details to the velocity field. That's what confinement is. And I'm going to go into confinement field, and I'm going to turn it on to velocity, okay? And I'm going to leave it at default, all right? So that's what that is, really. Nothing much to it. I mean, nothing much to it in my setting, all right? So it does mean a lot. Okay, so I'm going to move on to combustion now. So first, I'm going to enable combustion. And this ignition temperature is at what time or what temperature setting you want the fuel to ignite. Right now it's set at 0. We know the temperature goes between 0 and 2, somewhat around that region. Okay, so I'm going to change it to 0.4 because I know that worked really well for me. And I want to enable fuel threshold. Okay, so what does this mean? This means that any fuel that is above the value of 1 will not ignite. Okay, and that is imperative, because if you don't have this, if the fuel goes from 0 to, I don't know, 10, it will ignite all the way through. So you can actually cut off. This is like a cutoff field, but it's just the other way around. Anything above it will not ignite. All right. So I want to leave it at 1 because I know it goes around about 0 to 2. Okay. So if you want to check all of these numbers that I'm referring to all the time, if you go back into noise, you can tell, say there, 1.94 is the highest and 0 is the lowest, and for temperature is pretty much the same because they're identical. All right. So as you know, we have set that up here, minimum 0 and 2. Okay. So that's what that is. All right. Good. So that's what this is based on. All right. So next is advec fuel. You've already seen what kind of an impact it has. Okay. So fuel burn, how much of fuel you want burned per timestamp. I want to burn a lot of fuel. So I'm going to say 95% of the fuel. And how much of it do you want to be inefficient? Meaning how much of the fuel is not burned. The more you have it, the more the bigger the fire is going to be. Okay, so if you put it all the way up to 1, nothing is going to really, everything's going to burn at the same time. Everything's going to be inefficient, which means that it's still going to stick around and it's going to keep burning. All right, we don't want that. What I want is maybe a little bit. All right, so maybe 0.035. I think that's a pretty good number, to be honest. Okay, I'm going to do a little flipbook again, and I'll come back. Okay, so now we got everything here. Okay, so I'm just gonna, all right, there you go. So this is the one with the combustion turned on. So that's without it, without anything, with disturbance and turbulence, and this is with combustion combined. All right, so you can start to see the swirls coming into play as well, and it's starting to look slightly different to the first one. All right, at least I hope you can see it. But anyway, right, I'm going to stop all these, and I'm going to move on. So with Axiom Solver, as I mentioned earlier, I will only go through stuff that is important to this tutorial, not everything. Therefore, it is better for you to play around with these or even look at or purchase FX Mayhem by Stefan and see what these are actually doing. Okay, so I'm going to move on, right? So with combustion, here is the emission part. Okay, so I don't want any emission from density or pressure. Pressure is primarily for explosion kind of stuff. So what I'm going to do though is I want the emission of temperature to be 8, which is really high, but how much temperature to emit for every unit of fuel burned, because I want this to be a big fire. Okay, not a small fire, big fire. So I'm going to do a little flipbook and I'll come back. Okay, so here it is. This is the last one, and you can now tell there is a significant difference between everything, particularly the first one. So this temperature setting has really made it a lot better. Okay, so that's how it looks like at the moment. All right, that's good. As I said, it's going to get better and better. All right, good. I'm going to stop all this because my computer is screaming. Okay, good.